Walk onto a traditional factory floor and you will see a massive disconnect. Heavy machinery churns out products while operators scramble with paperwork orders. By the time someone logs a problem manually, the machine has already produced hundreds of defective parts. To solve this, you need a digital bridge between the business layer and the manufacturing floor. This is a manufacturing execution system, or MES, a software platform that tracks the transformation of raw materials into finished goods in real time. Before you can implement an MES, you need two things in place. First, an active enterprise resource planning system, or ERP, like SAP, to manage your broader business data. Second, you must have your physical production processes completely mapped out. By the end of this roadmap, you will know how to connect these systems to calculate your overall equipment effectiveness, or OEE, in real time. OEE is a metric used to evaluate how effectively a manufacturing operation is utilized by comparing its actual output to its potential output. Modern manufacturing moves too fast for manual updates. Surviving today's highly competitive landscape means matching the speed of business decisions with the exact speed of factory execution. Step 1 is mapping your operational challenges. Start by identifying your exact production bottlenecks. Many plants compensate for poor visibility by keeping a large safety stock of extra materials on hand, which ties up cash that could be used to grow the business. Next, look at how your data is collected. If operators are doing manual data entry at the end of their shifts, you have an information silo. The enterprise layer is making decisions based on yesterday's estimates rather than today's reality. Finally, trace the path of your defective parts. If a machine calibration error isn't caught immediately, a flawed component might travel to the end of the production line before quality control identifies it and scraps the entire finished product. Diagnosing these root causes ensures the MES targets the specific events that inflate production costs. Step 2 is architecting the bridge. To get your business software and factory machines speaking the same language, you need a framework. The international standard for this integration is ISA 95. Under ISA 95, Level 4 is the ERP, handling business planning. Below that, Level 3 is the MES. It translates business orders into a detailed schedule, factoring in equipment availability. These instructions are pushed downward to Levels 1 and 2, where machines actually build the product. The process also works in reverse. As the machines run, they send performance and status data back up through the MES to the enterprise layer, giving the business real-time visibility. This rigid boundary allows data to flow between planning and the machinery without manual intervention. Step 3 is testing that continuous data loop. You will initiate a test batch to verify that the ERP and MES are successfully trading data without any human translation. The first test verifies the download. The ERP sends a production schedule down to the MES. Check the specifics of this schedule to ensure accuracy. Here, we verify that the MES received the exact production request for 90,000 cases of the product. The second test verifies the upload, production performance. The MES sends active personnel and equipment status, like the palletizer operator, back to the business layer. Simultaneously, the MES tracks the material produced, ticking up the case count against the 90,000 case request in real time. This animated diagram compares your scheduled requirements against your actual material usage. By tracking the exact number of pans, lids, and liquid volume used, the system identifies material waste. Testing this loop confirms that the enterprise and the shop floor share the same live data set. Step 4 shifts the focus from software to the workforce. Your machine operators must transition from manual clipboard reporting to using the digital MES interface. A common failure point occurs when operators revert to keeping physical logs because they do not fully understand the new digital workflow. Leadership must enforce the MES as the sole source of truth for all end-of-shift reporting. There can be no secondary paper backups. If operators do not input accurate, timely data into the tablets, the entire architecture fails. Comprehensive workforce training is just as vital as the software implementation itself. Step 5 is the go-live. This dashboard calculates OEE by multiplying performance, availability, and quality. Because the MES tracks quality continuously, it catches defects instantly. You can configure automatic triggers. If quality drops below a threshold, the MES automatically pauses the production line. This immediate halt forces operators to address the root cause, preventing the machine from churning out additional scrap parts that would otherwise travel down the belt. Real-time OEE tracking and automated halts stop the production of scrap the moment a machine drifts out of spec. With the system live and operators trained, the facility is now officially operating within the Industry 4.0 framework. The enterprise ERP feeds production orders directly to the shop floor. In return, the machines report inventory consumption and performance metrics back to the business layer instantly. The financial impact of this loop is highly measurable. In automotive parts manufacturing, using an MES to catch errors early reduced the rate of scrapped parts from 2% down to 0.8%. The connected data also provides a secondary benefit. By tracking their own wear and tear, machines can trigger preventative maintenance work orders before a breakdown occurs. Your final step is to let the system run, and then review your first week's live OEE report. Find your lowest scoring metric, identify that specific bottleneck, and close the loop on your manufacturing upgrade.